Hello everyone and welcome to the Mathmatiker channel. In this video we're going to see how to solve the Diophantine equation, ax plus by equal 1, for integers x and y, where a and b are integers parameters. This kind of equation is also known as the Bézout identity as for regard of the French mathematician who studied it. And, as an example to illustrate the method we're going to use to find the values of x and y that solve this kind of equations, we have the equation 83x plus 13y equal 1. Before we see how to solve this equation, let's remind that the necessary and sufficient condition for an equation of this type to admit integers solution is that the greatest common divisor of parameters a and b is 1. In this case, we can see that 83 and 13 are both prime numbers, therefore, the greatest common divisor of these two numbers is 1. So we can fairly say that this equation admit integers solutions. The method we're using to solve the equation is the Euclidean division. This at first consists of doing the Euclidean division of the greater parameter, in this case 83, by the smallest parameter, which is 13, and to write the rest of this division as the basis of the dividend and the divisor of this division. We then do the Euclidean division of the divisor of the previous Euclidean division, which is, in this case 13, by the rest of this previous Euclidean division, and write the rest of this new Euclidean division as the basis of its dividend and divisor. We keep repeating this process successively until we reach an Euclidean division with rest 1. In the tables that appears, we have the quotient, the divisors and the rests of those successive Euclidean divisions. By going through this table from right to left, we can see that the rest 1 is equal to 3 minus 2, so we write 1 equals 3 minus 2. Then we have the rest 2 which is equal to 5 minus 3 times 1. By replacing 2 by 5 minus 3 times 1 in the first equality, we find that 1 is equal to 3 minus 5 minus 3 times 1. When we simplify this equality, we find that 1 is equal to 2 times 3 minus 1 times 5. Then we have the rest 3 which is equal to 13 minus 5 times 2. When we replace it in the last equality, we find that 1 is equal to 2 times 13 less 5 times 2, less 1 times 5. After simplification we find that 1 is equal to minus 5 times 5 plus 2 times 13. And from the table, again, we have the rest 5 which equals 83 minus 6 times 13. When we replace it in the last equality, we find that 1 is equal to minus 5 times 83 minus 6 times 13, plus 2 times 13. After simplification, we find that 1 is equal to minus 5 times 83 plus 32 times 13. So we have the equality, 1 equals minus 5 times 83 plus 32 times 13. We therefore deduce that the particular solution of our equation is the couple minus 5 and 32. Thanks for watching the video. If you find it useful, we invite you to click on the like button below and to subscribe to the channel as well as clicking on the notification button so you'll be informed of any future publications.